Hello everyone, welcome to AP Stats Unit 2 review. Okay, first we will talk about, so we're doing chapter 7. Again, we are using this textbook. Okay, chapter 7 is on scatter plots, association, and correlation. So, form. So when you describe scatter plots, you want to talk about form, unusual features, direction, and strength. So form is either linear, curved. Unusual features, talk about the outliers. Direction, is it positive, negative, or neither? Strength, is it strong, weak, moderate? And you can look at the correlation coefficient, R squared. And correlation coefficient is R, and it measures the strength of the linear association. And the conditions you want to look at is quantitative, is it a quantitative variable? Is it straight enough? Because R is only accurate for straight lines, and outliers, because outliers can really affect it. And so now we'll talk about, correlation coefficient, it tells you the strength and the direction. So if you look over here, R equals -1, tells you the strength, it is very strong, it's like a perfect line, and it is negative. And then 0.8 is pretty strong too. And R equals 0.2 is very weak, and R equals 0, there is no association. Okay, so correlation coefficient also has no units. It's always between -1 and 1. And remember, 1 is very strong, and it's like a perfect line. And they are very sensitive to outliers. And then correlation is not, with correlation, you cannot prove causation because of lurking variables. So an example is summer. It affects both variables, ice cream and sunburns. So ice cream obviously does not cause sunburns, but it might seem like that because there might be more ice cream sales and sunburns in the summer. And usually you say there's an association, not there's a correlation. And explanatory and response variables. So explanatory variable is on the x-axis, and it's what causes a thing, and response variable is the y-axis, and it's a result. Now, and the conditions are straight enough, does the plot thicken, and outlier condition. And chapter 8, the line of best fit, and the line of best fit is the same thing as the least squares regression line. And so residual is the observed minus predicted, so y minus y hat. And to find the slope, which we usually represent as b, you do the correlation coefficient times times sy over sx. And the line equation is y hat, so the predicted y, equals the y-intercept plus the slope times x. And now r squared, like the correlation coefficient, it tells you the strength of a linear association and how well the regression line represents the data. And you would say it as 77.3% of the variation in wind speed, or the y variable, can be explained by the pressure, or the x variable. So it's the r squared of the variation in the y variable can be explained by the x variable. Okay, now on to chapter 9, regression, outliers. So don't extrapolate because the trend can change. Outliers have a large residual. So in this example, you can see that blue X over there, it's much higher than the rest. So it has a large residual, so it's considered an outlier. And leverage is when it's far from the mean X. So this is the mean X, or actually no, the mean X should be more to left. And then you can see that is way to the right. So that would be leverage. And then influential is when a point changes the slope. So it seems if this wasn't here, it seems that it'd be a positive slope, but with this point, now it becomes negative. Okay, and a residual plot, you want it to be random. So that's like this example. So the y-axis is a residual. The horizontal line is at 0 and the x variable is on x-axis. And you want it to be random with no pattern or clumps. And that is, does the plot thicken condition. And now, last chapter of Unit 2, re-expression. So the goals of re-expression can be to make the distribution more symmetrical, to make the spread more similar, make the scatter plot more linear, make the spread more even, and that's does the plot thickening condition. And then you can square it, you can square root it, you can use log, the negative reciprocal, or a negative reciprocal of square root to try to make it straighter. Okay, that is Unit 2. Thanks for watching, everyone. Bye.